Hello, everybody. I'm here with Brian Cronquist. He's a vice president with Monolithic 3D, and he's been a prolific inventor, over 500 patents with the company. And he has a long storied history of semiconductor technology, including 34 years in the space plus nanotechnology research at Rice University. Brian, could you give us a little bit about your background?
Sure. After getting out of college, I joined Tech, which was part of Honeywell there, making ROMs for the games, as those of you remember the old Pong game and things like that. And then helped start a company called Sierra Semiconductor, which became Sierra PMC or PMC Sierra, excuse me, in Canada, and they're still existing and made all the modems kind of in the world for a while. And they've of course moved on beyond modems nowadays. And then we started a company in Singapore called Chartered Semiconductor. Lived in Singapore for a while, and that was fun. Had my kids there, and I adopted a daughter there, and very nice place. And I visit there occasionally. Making me old. We just had a 36-year reunion there for the beginning of Chartered Semiconductor. That turned into Global Foundries, which some of you may recognize now. That's where Chartered Semiconductor became Global Foundries. After that, worked at Actel, where we did different kinds of FPGAs, field programmable gate arrays, some radiation hardened, some not. So there's some on the moon, on those rovers, chips like that are on Mars, things like that. And then and running the R&D group there. And then a friend of mine introduced me to Svi Orbach, who was starting a company with some ideas on how do we make a three-dimensional FPGA. And so we started as New PGA Corporation, and we quickly figured out that, hey, once we knew how to make a three-dimensional FPGA, we then knew how to make anything in 3 dimensions. And the idea here is to make the three-dimensional integrated circuit in the wafer fab, not in packaging, where packaging is one at a time. So you end up having more cost per part, per three-dimensional integrated circuit. We're doing it in the fab, so you have a wafer, which has been the whole reason that this whole industry has been so cost effective, is that not only is it scaling, but that we have each wafer is a batch. So in that batch, we have hundreds of die, hundreds of products that come out of that one wafer, and you process that wafer one at a time. So it's just been a fun thing to think about and to write patents and to work with patent examiners and especially with you on how to get our ideas so that we could make money with them. Because a lot of people make patents, but how do you make money with the patents?
Well, fantastic. So this technology, with the 3D layering on directly on the semiconductor, is going to enable flash devices to have much higher density, and probably could be used also because the memory is also used in the GPUs. You can also now enable a much more higher density, I guess, the arrays of
Well, it becomes
the
faster and you
processing
spend
arrays in the
less energy
GPUs.
because your memory is now very, very close. You're within tenths of microns of the processor, of the transistor switches. So now we're spending a lot less energy. You don't have to go out and fetch stuff in a cache or on another chip. And so it makes the GPU way faster.
Yeah, no, that's exciting. I read the other day that I think people are moving towards Cerebrus approach, where it's a wafer scale processor and memories and everything is on a chip. And when you can have such a short intercommunication length, you're going to have much higher, bandwidth and processing
Yep.
capacity. So
And
that's
then
fantastic technology.
they'll probably likely step on some of the patents things we've already thought of and filed and gotten claims issued with your help again. And
Well, tell us, you've been such a prolific patent writer. What is your secret to success?
secret to success is that to me, the key thing is the examiner is your judge. The examiner is a person. It's not a jury, it's a judge. He or she is a judge. Technical judge, but still a judge nonetheless. And so it's best to have a conversation, just like we're having a conversation now, to see where is that examiner coming from. Can I convince that examiner that I do have a invention, something that is novel and is not obvious, but then it's just a matter of language after that to actually get the patent granted or issued, and so we're allowed essentially then issued. And so it's more working with that examiner and getting to know the examiner. What is it that they think is important? And it actually makes my patent stronger I always tell the patent examiners, I want the best patent. I just don't want numbers of patents. I want the best, strongest possible patent. And together in a partnership, the examiner and me, we're going to make the best possible patent.
Fantastic. So now you have very long uh, patent application and lots of drawings. Why is that important?
Well, what we do is we try and put all the ideas that we can in an area all in one disclosure, and or we build it through CIPs, but we eventually have one disclosure. In fact, our largest disclosure is over 1,200 drawings and maybe 700 pages of description or prose. And what we do there is we can then keep that application alive by uh, filing continuations or CIPs, depending upon what we're doing or what we need to do from a priority standpoint, um, and still use the same patent and the same disclosure, I mean, and the examiner then gets to know it really well. We also then can use that patent and I mean that disclosure and file it in a different way and still have a different examiner look at it. So again, we're getting uh, claims that have been looked at by multiple examiners and looked at from multiple specifications with different aspects of the similar invention.
Fantastic. So tell us a little bit about your vision of, when you work with the examiner, you always set up meetings with them and talk to them. Why is that important?
Yeah, again, the examiner is human. And so that face to face interaction, or at least that voice to voice interaction, we get to know each other. And I sometimes even talk to the examiners offline. I will, I get to know when they're going to retire or how many kids they have. And I talk about things that are going on in my life as well. Loss of our son recently, things of that sort. And I found some people who relate to that. And so again, it's a human process. It's not just a technical process or a legal process. It's also a human process, just like a tort law, say, something in that area might be. So we just try to get to know the examiners better and be upfront and say, again, I'm not wanting to get a patent fast. I want to get a strong claims, strong patent, and because there are going to be a lot of people in this business. We know that three-dimensional integrated circuits made in the cheapest possible way are going to be the next big thing in the industry, in the semiconductor industry, not from an application, but from how you actually manufacture the chip. How do we keep ourselves on that economic law called Moore's Law? That's an economic law, marketing law. How do we keep lowering the price of that chip or doubling the function of that chip for the same price if we don't figure out how to go in 3 dimensions? It's just like what society did. We had farms, and then we started building roads as interconnect. So it's kind of like transistors of the farms or the houses, and the interconnector of the roads. And then we got closer together in suburbs. But then we figured out how do we get any denser? We can't. And it takes a while to drive from one person's house to another. So instead, we then built skyscrapers. But the problem with skyscrapers is you might have 5 or 6 elevators, yet you have a huge 10,000 square foot floor. How are you going to get that interconnect horizontally to be and vertically the same? And that's what we worked on. And we found 4 different ways, 4 fundamentally different ways that a regular wafer fab, a regular manufacturing facility, can make a monolithic 3 dimensional integrated circuit where they can have the vertical connection density equal to the horizontal connected. We've always enjoyed horizontal. That's been part of our scaling, what's called Dennard scaling. But now, how do you do that now when you have the skyscraper? So now, instead of having the Empire State Building with a few elevators, we now have an elevator in every office.
That's amazing. With 500 patents in hand, so that type of approach definitely is successful. That's a testimony to that. Um, the what's the outcome of all this hard work? How were you able to succeed with the 500 portfolio?
Yeah, we've just been After building portfolios, we just in the last couple of years been going out to monetize, and we recently successfully gotten a large sum of money to license for 5 years to our portfolio to one of the largest semiconductor companies globally in the world. So we consider that kind of a stamp of approval on the different kinds of ideas we have and the way we went about making monolithic 3D happen on paper in a patent. And now it's being done in the industry, and there will be more people. You'll see announcements from us, I'm sure, over the coming years.
Well, that's amazing to get the top semiconductor company in the world to license your technology. With all that wisdom, how would you recommend a new company, uh, to follow your footsteps? What should how should they think about the process?
Well, take control of it. Don't just work with the lawyer and learn how the process works. Don't just depend on the patent lawyer to do it. As well, I'd work with a small firm like how we work together, you and I, instead of some big company where you're kind of lost in the shuffle and you get just the automatic way of doing things. You want to think out of the box. You want to take a little more time to establish relationships. You want the inventors to talk with the examiners. Most of the examiners I've ever talked with really appreciate talking to the inventor because they want to learn about that. In fact, so much so that Svi Orbach, the president of Monolithic 3D, CEO and president, founder, he he was invited by the patent office, the U.S. Patent Office, to give a 3-hour lecture on the whole history and why 3D IC, three-dimensional integrated circuits, are something that the world needs, and what are all the terminologies and the various structures and the options and what people have already discovered. Of course, what monolithic 3D has been doing as well. So now they use that to train, many hundreds of the examiners in those specific technology centers that deal with the kinds of applications that we do or people in our business do.
Fantastic. Well, thank you for that wisdom, and we definitely would expect you to reach 1,000 in another few years, 1,000 patents. All right. Well, thank you so much for your time.
You're very welcome, and thank you for the opportunity.
Take care, Brian.
Take care. Bye bye.
Review the structure of a patent. In this case, it is a monolithic 3D patent with V. Orbach as the inventor, and the patent number is 12041,792. It issued on July 16th, 2024. And so here's various informations about the applicant, the assignee as Monolithic 3D Inc., and then here's a representative figure. So the title of this is 3D Memory Semiconductor Devices and Structures with Memory Cells. And so immediately after the front page is a series of drawings that illustrate the operation of the invention. In this case, this is a three-dimensional set of structures, semiconductor structures for memory. And they have various illustrations of the type of gates, the channel, the Schottky barrier, and things like that typical in semiconductor. And you see here also, here's a circuit diagram of a typical memory device, a 3D memory device. More figures, lots of figures. As they say, there's pictures are worth 1,000 words. So here you see exemplary current and voltage diagrams of the semiconductor device. More diagrams illustrating the stacking of the 3D memory chips. And then we finally get to the actual text of the application. This particular diagram here illustrates the various decoders, the multiplexers, and the buffers and memory select switches. Right. Typically in a patent application, you have a background of the invention, you would have a field of the invention, and you discuss the background art. Typically, you discuss you can certainly discuss what prior patents in the space, and Monolithic 3D, they have quite a bit of their own prior art here. There's a summary section of the invention where typically summaries track the claim language. It's that way to avoid variations between some people claiming that the summary is the invention versus the claim. So to avoid that, you typically track the summary and the claim. So you can see here, there's a lot of embodiments here, a different aspect as they call it. And so you got in another aspect, in yet another aspect, in another aspect. And so each of these aspects is a different inventive aspect. And then you get to, after the summary, then you get the brief description of the drawing. And here you will see that each drawing is outlined in this brief description. And then you got quite a bit of detailed description here. And so the descriptions refer to the numbers in the diagram. So that way it dovetails with each other. So for example here, figure 1A illustrates a multi-layer 106 structure formed over foundation structure 108 with pattern mask hole 109 after holes 102, 104 been etched through. So they refer to the figure. And you can see that in figure 1A, you'll see all those numbers in there. So this is 1A. So you'll see the numbers 109, 107, 108, 105, 103, 102, and each number would be described in the text in the description section. And you can see how it can get very long if you have a lot of figures. So this continues on, and then at the end, when you see the claim is really what the invention is about. So if you invented a car, the claim of a car might be as simple as, I invented a vehicle having a frame, 4 wheels, and an engine rotating the wheels. But the description of how that works can take you 50, 100 pages, right? So here, the claim, if you look at claim 1, it covers a 3D memory structure device with a structure with memory cells, wherein each cell has at least one memory transistor, and when the transistor has a source, a drain, and a channel, when the memory cell has a charge trap structure and is self-aligned overlaying another structure, when the memory transistor both being processed in the same lithography step, and then a control level. So that's the structure at claim 1. And then you got a bunch of dependent claims. So dependent claims are instantiations of claim number 1, but a variations to it. So an example might be in the car. You may have a car with an engine, and then claim 2 might say the car of claim 1 wherein the engine is a gas engine. And then claim 3 might say the car of claim 1 wherein the engine is an electric engine, for example. So that would be called a dependent claim because it depends from claim 1. So you would have typically around 20 of these claims because the patent office gives you 20 in one filing fee. If you exceed that, you're going to have to pay more fees. So if you want to conserve your money, then you just keep it at 20 claims. So that's an example of what a three-dimensional chip patent from Monolithic 3D looks like. If you have any questions, please feel free to contact us. Take care. History of this patent application that resulted in the issue patent that we reviewed. This was filed on March 14, 2024. The serial number is 18605-401. The M3D is a docket identifier. And the title of this case is called 3D Semiconductor Devices and Structures with Memory Cells. So it's a utility application. It was assigned to an examiner, Han Yang, in a group art unit 2824, which is semiconductor. The assignee for the publication is Monolithic 3D Inc. The inventors include Zvi Orbach, Jin Woo Han, and Eli Lusky. And the applicant is Monolithic 3D Inc. So let's look at the history that in that case. So here what we see is that the case was applied in March 2024. It included the specification, the claim, the abstract, the application data sheets, the oath, and then the fee payment. Okay, so then the application was accelerated because of this petition and request and the grant on the same day. Basically, petition to accelerate due to age of one of the inventor. And in this case, the patent application just flew right through, and they got a notice of allowance on May the 13th, and they paid the fee on June the 10th, and it issued on July 17th. So this is an example of how you speedily go through the patent office. File on March of 2024 and allowed in July, basically 4 months, almost 4 months to the exact date. And the claims are very broad, and this result in licensing by the biggest semiconductor company. So congratulations to Monolithic 3D and to Brian for doing an excellent job. Thank you.